First of all, I will explain what is the Diels-Alder reaction. Diels-Alder reaction is an organic reaction that is used to convert a conjugated diene, a molecule with two alternative double bond, and a dienophile, an alkene, to a cyclic olefin. This process is concerted, which is bond, form and breaks at the same time. The entire reaction takes place in one step in the presence of the heat. The class of the Diels-Alder reaction is the cycloaddition. Diels-Alder reaction is stereospecific. Its substituent attached to both of the diene and a dienophile. It retains the stereochemistry through the reaction. Here is some of the examples of the Diels-Alder reaction.
So today I want to share about function of apparatus in this experiment. First is round bottom flask. Round bottom flask is used in a laboratory for holding chemical liquids and solution, which has a spherical shape for uniform heating and one or more long cylindrical necks. Second is distillation column. Distillation column is used for transfer heat energy or enhance material transfer. Third is condenser for distillation. Condenser for distillation is used in distillation to cool the hot vapors and condensing them into liquids for separate collection. Next is thermometer. Thermometer is used for measuring temperature in experiment. Next is Erlenmeyer flask. Erlenmeyer flask is used for storing and mixing of chemicals in a laboratory setting. Lastly is vaginal funnel. Vaginal funnel is used to filter liquid from solid.
There are two steps in Diels-Alder reaction. First is preparation of cyclopentadiene. First, put the cyclopentadiene 40 ml into a 100 ml flask. Complete the setup with a fractional distillation column and condenser for distillation. Second, cool the collector flask, aluminium flask, 100 ml in the ice bath. Third, boil the cyclopentadiene and distill at 40 to 43 degrees Celsius. Second is reaction of cyclopentadiene with malic anhydride. First, dissolve the fine powder of malic anhydride 3 g into 10 ml of ethyl acetate by steam warming. Second, add lagrin 10 ml and cool the mixture in the ice bath. Third, mix the cyclopentadiene 2.5 g obtained from the previous procedures and shake the exothermic mixture in the ice bath until it precipitates as white solid. Next, heat the mixture in the ice bath until it dissolves and let it crystallize. Filter the crystal formed by using the vaginal funnel and wick the product. And the last is record the melting point and the infrared spectrum of the product.
The reaction between cyclopentadiene and malic anhydride forms two stereoisomer products, namely the exo and endo products, which are cis-5-norbornene exo-2,3-dicarboxylate anhydride and cis-5-norbornene endo-2,3-dicarboxylate anhydride respectively. Between these two isomers, the main product is the endo product. To explain this occurrence, the reaction mechanism diagram is used to get a better picture of it. In the endo transition state, the carbons which become the C2C3 double bonds are positioned right below the carbonyl carbon of the dienophile. In the exo transition state, the electron withdrawing group points away from the C2C3 carbons. With that, secondary orbital interactions are possible in the endo transition state but not the exo transition state because the C2C3 orbitals of the diene HOMO are positioned close to the C double bond O orbitals of the dienophile LUMO, which allows interaction, and this is not possible in the exo transition state.
The conclusion of this experiment is the purpose of this reaction was achieved. The evidence from the qualitative testing forms in the laboratory confirms the formation of 6-membered ring. By cycloadditions, also known as a Diels-Alder reaction, the yield of the product was 11.95%. Overall, the reaction proved to be successful. A diene reacts with a dienophile to produce a cyclic alkenes. This was shown to be true through IR spectra test, melting points of the product of the reaction. As expected, as the product was further reacted, it became more purified.